Okay, so one thing that really puzzles people is IP addresses. We talk about IP addresses having to be unique all around the world, but as you've seen from our network here, Bob's house has got IP addresses 192.168.0 dot something, and here we go onto Anne's house 192.168.0 dot something as well. So clearly end devices on home networks all seem to have very similar IP addresses, usually 192.168.0 something or 192.168.1 something. So if all these devices have got the same address, how are they seen as unique in the internet? And how does traffic, when we send out a request, come back to that device? Well, it's all to do with what's commonly called network address translation, or properly called port address translation. As you can see from our network here, our routers, their external addresses are unique, 82.10.0.101, and the cable modem is 82.10.0.100. So these are given to our routers by the ISP, and they are unique in the internet, and they're what are called our real world IP addresses. So hidden behind our routers we use 192.168 addresses. They are called private addresses, and basically if we send any traffic out from our internal network out to the outside world, we borrow the address of our router on the way out. That way the packet can come back to our router and then is translated and sent back to the actual PC. So it all sounds really complicated, but it's not actually that bad. So let's have a look at in action. We'll go from Bob's PC and we'll just go to in fact we're not going to browse this time. What we're going to do is going to go to the desktop, just close down the web browser. We're just going to do a basic ping. We're going to ping www.bcu.ac.uk. Let's just check that works. There you go, we get our replies. Brilliant. So we know that's working. Now let's do this in the simulation mode. So we go to simulation. We'll clear all the filters, we'll edit filters, we're just going to look at pings, so we want ICMP, there we go, and that's all we're interested in. So let's just do that again. We're going to ping bcu.ac.uk, so we've started the ping going. Let's just forward time, here's the packet. So let's just have a look at the packet now as it arrived on the router. Now notice there's an inbound PDU, so it is coming into the router. If we have a look in the router here, you can see the source address is 192.168.0.103, which indeed is Bob's PC. Let's just go and hover over that. Let's have to close that window to do it. There you go, 192.168.0.103, and we're going all the way over to BCU, which if we hover over here you can see is 193.160.133.109. Quite a complicated address. So does that tie up with what we're seeing here? So here's our inbound packet. Source address 192.168.0.103. Yes, that's Bob's PC. Destination address 193.160.133.109. Yes, that's correct. So as the packet hit the router, it was as we expected with a source and destination address. But let's have a look at the outbound packet. So it's now leaving the router and going into the outside world. What you'll notice is the source address has now changed. The source address is 82.10.0.101, which is our real world IP address on the end of our router. And the destination IP address, that's still the same. Okay, so what does that mean? It means now as this packet is going into the internet, the source address is unique. It is our external interface of the router. So we can send the packet in, we can send it out, it goes out to the ISP, ISP sends it out to the internet, and the internet sends it to the BCU web server. And then our reply comes back. Let's just have a quick look at the reply. Doesn't really matter which one I look at here. Where's it going to? Where's the destination? 82.10.0.101. That's why the internet can route it, because this is a real world IP address. The internet will know this belongs to our ISP, and our ISP will know that it's our router. So the packet will come all the way back. Let's just forward it back. There you go. It's been sent from the internet to the ISP, and the ISP looks at it and says, oh, we know that's up there, that's in Bob's house, so we'll forward that on to Bob. Let's forward it all the way back to Bob. Let's get it into his router. It's delivered into the router, and let's have a look what happens when it gets into the router. What did it look like when it came in? Yeah, it was destined for 82.10.0.101. That is the router. It's got there now, and it's from the web server. If we look at the outbound details, the outbound destination now is 192.168.0.103. So the destination address has been swapped now to send it back to make sure it gets to the actual right device, which obviously was Bob's PC. So it's really clever. No matter which PC sends the information out, its own private 192.168 address is swapped by the router and replaced by the real world IP address. We borrow that address and we send it to the outside world. The outside world knows where we are, so it can send it back, and the router translates that address back to our own internal addresses. And the router is really clever at being able to do that, and it can handle multiple conversations at the same time from multiple devices, using some really clever ways to do with ports to keep a track of what's going on. And it's known as network address translation or port address translation.